Hi everyone, and welcome to section 4.5, which talks about using the slope-intercept form of an equation of a line. And so the goal of today, or this video rather, is to recognize the relationship between the graph and the slope-intercept form of the equation, identify it, graph using it, what's the most convenient method to graph a line, use that in applications, and then identify parallel and perpendicular lines with their slopes. So let's get started. First of all, what is the slope-intercept form of an equation of a line? It's this. It's very popular, y equal mx plus b, where m represents the slope and b is the y-intercept. So if you have the y-intercept located at a point 0, comma b, it's that same b, okay? So let's say here we have use the graph to find the slope and y-intercept is equal to 2/3 x minus 1 and compare the values to the equation. So look at this here. We know that the y-intercept here is -1, so b is equal to -1, right? And then to calculate the slope, so let's go ahead and find here. Here's another point where it crosses. It goes up 2 and then over 1, 2, 3. So the slope is 2/3. But we could have also done that by just looking at the equation, right? Because the form is y equal mx plus b. That means that whatever the coefficient of x is, that's the slope. So m is 2/3. And then whatever the constant term is by itself, that's b. So b here would be -1, okay? All right, so let's go ahead and do a couple. Let's identify the slope and the y-intercept of this equation here. So what's the slope and what's the y-intercept? So the slope is right here. So m is equal to -3. So we usually leave slope as m. And then the y-intercept is 5. Intercept. You could say 5, or you could say b equal 5. That's fine. So the next one, slope, y-intercept. So slope, which is depicted as m, -4/3. And then the y-intercept is +1. Okay, let's do another one here. Oh, it's not as easy to tell, right? It's not in the right format. So we need to get it there. So we have x plus 2, y is equal to 6. How do we get it? We solve for y and then look at that, the equation. So 2y is equal to -x plus 6, and then we're going to have to divide everything by 2. So now y is equal to -1/2 x plus 3, because 6 divided by 2 is 3 today. So now that I see this, I can tell you that my slope is -1/2 and that my y-intercept is +3. Okay, so let's do the same thing here. We have 3x plus 2y is equal to 12. We want to get it in the form y equal mx plus b. Okay, so we subtract 3x from both sides. And we get 2y is equal to -3x plus 12. Divide both sides by 2. We get y is equal to -3/2 x plus 6. So now the slope is -3/2, and the y-intercept is +6. Okay. Now, how do we graph using graph a line using slope and y-intercept? So first of all, we need to have the equation of the line in that form, y equal mx plus b. Okay, so once we have that, we can identify what the slope is, what the y-intercept is. Then we use the y-intercept as our starting point, and then we use the rise over run formula for slope, to identify rise and run, and then graph the next points, okay? So here's an example. We want to graph this equation, y equal -x plus 4 using slope and y-intercept. So we have here, let's see, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, so here, this equation, the slope is -1 because that's what's in front of the x. It's not, if it's nothing, we assume it's 1. And the y-intercept is 4. So that's our starting point, okay? So really important, okay, when you're graphing. So you just go up 1, 2, 3, 4. That's the point. That's your b, 4. And then the technical point is 0, comma 4, which is fine. And then your slope, we can rewrite any whole number as over 1. So this would be -1 over 1. So that's down 1 and to the right 1. So from here, we would go down 1 to the right 1 dot. Down 1 to the right 1 dot. Down 1 to the right 1 dot. Okay, so down 1 to the right 1 dot. So then we just connect those dots here. You don't have to do 5. You could do just a couple. It's fine. And this is the formula. This is the equation -x plus 4. And that's it. Not too bad. Let's do another one. Okay, so now we have here y equal 2x minus 3. So right away, what's the slope? That's 2. What's the y-intercept? -3. Okay, fine. So here I go. Here's my plane. 2, 3, 4, 5. 2, 3, 4. Let's do like 5 each, I guess. Or so. Okay, so starting at -3, that's that -3 right there. That's our starting point. And our slope is 2 over 1, so that's positive, in the positive direction. So you would go up 2 over 1, make a dot. Okay, so we would go up 2, so 1, 2 over 1, and then we would make a dot. Okay, so that's kind of how we're doing it. We can keep going. We could go up 1, 2, so up 2, and then to the right 1. Okay, and that's here. That would be our next one. And then we just draw a line through those, connecting those dots. Okay, and that's y is equal to 2x minus 3. All right, so let's look at some some methods to graph lines. So far we've learned point plotting, right, where we can make a table and then we find 3 points and we plot them and we draw the line. We just talked about slope-intercept form, where you have it in this form and you start at the y-intercept and then you graph using the slope. We've also done intercepts, where it's similar to point plotting, but more specific in that you just plug in 0 for x, 0 for y, and then a random third one. Okay, and then the last one would be make sure to recognize vertical and horizontal. So if it looks like this, right, or if your graph is like x equals some number, right, it's a vertical line. And if your equation is a y equals some number, then it'll be a horizontal line, you know, going this way. All right. Okay, so how do we know what's the most convenient method to use? Okay, so if it only has, so we have to think about the equation. If it only has one variable like x equals or y equals, that means it's either vertical or horizontal. And if it's x equals, it's vertical. And if it's y equals a number, it's horizontal, okay? Passing through at that number, okay? Now, if y is by itself and it's in the form y equal mx plus b, we can graph using the slope and y-intercept, okay? And if this equation is in this form ax plus by is equal to c, it might be easier to just find the intercepts, right? And do a table, intercepts, third point, and then graph. So here's some examples. So when you look at this, you should be able to start recognizing what method to use, okay? So x equal 2 is a vertical line, boom. Y equal 4, that's a horizontal line going through 4. -x plus 2y is equal to 6. We're going to do intercepts here for both these two, because it's not solved in the y equal mx plus b form. Here it is, y equal mx plus b, so we're going to use slope-intercept form, right? Okay, so that's for the last two. So let's go ahead and look at these and tell me which, tell the recording what's the most convenient method to graph each line, okay? So for the first one, okay, so you need to recognize what this is. This is a horizontal line. So if you were to graph it, you know, let's say this is it, and I'm going to graph it. Wherever -6 is, that's where the line goes through. So -6. Okay. And then this one, we would just need to do, since we don't know, it's not in y equal mx plus b form, we could do intercepts, okay? We would make a table and then plot the points and then draw it, okay? Here, for C, you just need to know what's the method. We need to recognize that this is a vertical line because it's x equals, and then it would be x equals 7. So wherever 7 is, it's a vertical line going that way, okay? And then this one is 2/5 x minus 1. This is y equal mx plus b form. So we would use slope-intercept, right? Where we would first graph the y-intercept, the point, and then use the slope to find the next one, and so on. Okay, let's talk about parallel lines. What are parallel lines? They're lines that are in the same plane that never cross, right? So in order for them to never cross, they have to have the same slope. They have to behave exactly the same way so they never touch, okay? So parallel lines have the same slope, but they have different y-intercepts, okay? So if you have two slopes of two different parallel lines, then that means that the slopes are equal. And also parallel vertical lines have different x-intercepts. So let's say you have one here, you can have another one here, right? They're parallel, but this one like could be crossing at 2 or something, and this could be like 4 or something, okay? All right, so how can we predict, identify parallel lines? So we need to make sure that we can recognize that they have the same slope, okay? So if the lines have the same slope, then the first graph is parallel. This little symbol means parallel. The double straight lines, vertical lines, to the second equation, okay? All right, so that's parallel. Perpendicular is basically lines that are in the same plane that form a right angle. So they look like this here, right? The x and the y-axis are actually perpendicular to each other already. So properties of a perpendicular line, that if I multiply the two slopes together, I get -1. So in other words, one of them is a negative reciprocal of the other, okay? It doesn't matter, but vertical lines and horizontal lines also note that they are perpendicular to each other, okay? Now let's do a problem here. We have y equals -5x plus minus 4 and x minus 5y is equal to 5. We want to see if they're perpendicular. So we have y equals -5x minus 4. So the first slope is -5. So now we need to find out the other slope. So we have x minus 5y is equal to 5. It's not in slope-intercept form, so let's put it there. Let's get it that way. So -5y is equal to -x plus 5. Divide everything by -5. Okay, we get y is equal to, and then this is a 1, so -1 over -5 is just 1/5 x, and then 5 over -5 is -1. So all we're looking at here is the slope, so the second slope is going to be 1/5. So you see that they are negative reciprocals of each other, okay? So you could also, let's see what else, if you multiply them, times m2, so -5 times positive 1/5, I should get 1 back, -1, and I do. So that's how another way you can check if they're perpendicular. All right, and that's it for section 4.5. So for this exercise, you can start at 291 and at 335, and then skip the problems until 351 to 381. Now, again, you can do odd or every other odd. That just depends on your schedule. So good luck and happy studying, and we'll see you in the next video.